Hello everybody, my name is Batmaz and I am going to present our work called Precision versus Power Grip, a comparison of pen grip styles for selection in virtual reality. I would like to start my presentation with our previous work called Is the Pen Mightier Than the Controller, which is published in VRST 2019. In this study, we investigated user performance for 3D distal pointing in virtual and augmented reality with three different input devices: a mouse, a VR controller, and a pen-like device. Overall, our results indicate that a pen is better, or mightier in this case, than a controller in all objective measurements. We also found that there is no significant difference between the pen and mouse in most measurements. So this result raised the following question: why a pen-like controller is better than a VR controller? Is it because of different grip styles? In this study, we decided to seek the answer of this question. Imagine that you are holding a pen in one hand and a hammer in other hand. When you look at how you hold these tools, you will realize different grip styles. Also, when you want to use these tools, you use different muscle groups. When you hold the pen, the dynamic tripodal finger configuration offers more precision at the tip of the pen compared to holding a hammer. Recently, several VR and AR pens have been introduced for virtual content creation, such as Maskless, Logitech VR Ink, and HoloStylus. Before going further, I would like to explain precision and power grip. The type of movements that describes interaction with current VR controllers best is prehensile movements, and in this study we use Napier's classification while subjects holding a VR controller. In Napier's work called The Prehensile Movements of the Human Hand, he did the classification of the movements of the hand when it positions an object while that object is being held in the hand. If the object held in a clamp formed by partly flexed fingers and the palm, counter pressure being applied by the thumb lying more or less in the plane of the palm, this is referred as the power grip. The current VR controllers use this grip style. If the object pinched between flexor aspects of the fingers and the opposing thumb, this is called precision grip. Pen-like controllers use this grip style. In this work, we investigated two hypotheses. The first one is holding a VR controller with a precision grip significantly increases user performance compared to power grip. The effects of wrist, hand, and fingertip positions on user performance for human-computer interaction has been previously studied for a 2D mouse. In this study, we explore how a precision grip, which is used for pen-like devices, for example, during drawing, affects user performance in comparison to a power grip, which is how current VR controllers are typically held. The second one is user performance does not vary with different target depths while holding a VR controller with the precision or power grip. The limitations of the depth perception in VR systems have been previously studied, and user performance in VR systems has shown to be negatively affected by stir display deficiencies, such as Vergence accommodation conflict. We think that stir display deficiencies negatively affect the user performance, and the grip style will not vary with the results. As I mentioned earlier, in this study we compared two different grip styles: precision grip and power grip. Also, participants performed the task with circular target arrangement at three different depth distances: 0.4, 1, and 1.6 meter away from the user. In our pilot studies, we first tested 0.5 meter as the closest distance, but some subjects were not able to reach the targets comfortably and had to extend their arms. We also tried 0.3 meter, but then subjects were not able to see all the targets at the same time. So we chose the shortest depth distance as 0.4 meter, well within the peripersonal space, where subjects were easily able to reach all the targets as in virtual hand. This was not possible in other target distance conditions, so we used raycasting for further away target selection. We increased the depth distance linearly, while still keeping the distance condition comparable to our previous work, which were 1 and 1.5 meter. When we look at the results for this depth distance, we see that with the increased depth distance, it takes more time for subjects to do the experiment. Then we can see that with the increased depth distance, subjects start to make more errors. We can also see that when we increase the depth distance, subjects' throughput performance decreases. All these results were expected and they are also in the line with the previous work. When we look at the grip style results, we only find significant difference for error rate. And in these results, we found out that precision grip decreased the error rate when it's compared for the power grip. According to subjective results, 9 out of 12 subjects preferred precision grip over power grip. 10 of them preferred precision grip in peripersonal space, which was 40 centimeter. 6 subjects preferred precision grip for further away targets, which were 1 meter and 1.6 meter. When we look at the comments about precision grip, subjects said they felt more natural with the precision grip. It was easy to adjust the cursor. They felt like they had better performance with precision grip, and it was better to aim the cursor with the precision grip. When we look at the comments about the power grip, subjects felt more comfortable. They said precision grip had far too much jitter and instability, and they said their hand shakes too much in the precision grip. There was also one subjective comment says that when the targets were small and very far away, the power grip was easier to use for a longer period of time. For short and precise selections, precision grip was easier. I will come back the jitters and instabilities in the further discussion section. So when we go into our discussion section, the first thing we can say about the grip styles, the subjects had fewer errors with the precision grip. And also, majority of our subjects, 9 out of 12, preferred the precision grip. As you know, that the precision grip requires subjects to use their multiple fingers and they had to rotate their wrists so they can adjust the position of the cursor. However, with the power grip, subjects had to move their whole arm, which were a larger movement, which is more difficult compared to precision grip. And we think that this is why the subjects preferred precision grip over power grip. According to these two results, we can say that our hypothesis is supported. Precision grip increases user performance compared to power grip. When we look at the depth distance results, we saw that by increasing the depth, subjects were getting slower, they were doing more errors, and their throughput performance decreased. And we didn't find any interaction between distance and the grip style, which also supports our hypothesis too, says user performance does not vary with different target depths for different grip styles. When I was explaining our hypothesis too, I mentioned about the stir deficiencies and how they affect the user performance. So I want to go a little bit deep into our depth distance and grip style results and why we did not find any significant difference between these two factors. Our first explanation is that subjects continue to use their fingers to fine adjust the pen position even for close targets in peripersonal space. The second one is that peripersonal space target selection was easier compared to further away target selection in virtual reality, which is why we did not observe any difference in performance for different grip styles for close targets. Subjects might have been able to perform the experiment without small adjustments, yet reliable distinguishing between these two potential explanations requires additional hardware, such as tracking finger movements. Our third explanation is about the design of the VR controller, because participants also mentioned about the how weight distribution and the width of the VR controller affect their performance. We also find different results from PUM 2019, which is our previous study. Based on the subjective results and the user comments, we decided to explore the hand tremors or the hand shaking that we have on the VR controller. If you look at the literature, we can see that jitter, which is also called the fluctuations in the signal, has a negative effect on the user performance. Above 0.5 degrees, user performance significantly drops with the jitters. As you know, throughput is calculated with the effective index of difficulty and movement time. Effective index of difficulty is related to effective target width, which is calculated with the standard deviation of the selection points. If a jitter, or increased jitter in this case, is going to derive the selection points, the standard deviation of these points is going to increase, which is going to increase the effective target width, and which is also going to decrease the throughput performance of the user. And we think that this is why the user performance is different with the PUM 2019 result, which is our previous experiment. Another explanation of the difference between our results and the PUM 2019 is that in our studies we used an infinite ray, where the array starts from the controller and it just goes into the point where the user points. But PUM 2019, they used a VR controller, and this VR controller was placed on a plane with the same plane as the targets placed. We choose to use VR in our study because currently VR-Link is a pen-like device which is compatible with the Lighthouse-based VR setups. In PUM 2019, we tried to use a VR controller with the precision grip, but because of the weight distribution of the controller, we were not able to use that VR controller in our experiments to measure the human performance. In this work, we use VR Ink Pilot Edition. Currently, there is no final product of the VR Ink, so we had to use the Pilot Edition of the pen-like device. Also, in this study, we did not use any VR controllers, and we did not compare VR controllers with the pen-like device, and we only decided to focus on grip style. Moreover, we used HTC Vive Pro, which is suffering from screen door effect, and this has a negative effect on the targets at large depth distances. As a conclusion, precision grip significantly increases user performance, and subjects prefer precision grip over power grip. In the future, we want to focus on precise and accurate interaction styles, and we want to find optimal combination for user performance. Thank you very much for listening. I would like to answer your questions.